Welcome to our video solution for problems 6a and 6b from Superquiz 2. Here we're given two different differential equations along with initial values, so these are initial value problems, and we're told to solve them using Laplace transforms. We can use our Laplace transform table as much as we like. So let's try part A first. So here we have a second order differential equation, forcing function e to the negative t, and we're going to apply the Laplace transform to both sides. So we're going to have to remember our formula for the Laplace transform of a derivative, and by remember I mean look it up in our table. So when we apply L, we're going to get s squared Ly minus sy of 0. But now y of 0 is said to be 0, so we don't need to worry about that next term. Then we'll get minus y prime of 0. Okay, that's 1. Plus 2 times, now y prime, when we take that Laplace transform, we're going to get s Ly minus y of 0, which is again 0. So we just get the 1 term. And then we have plus 3 Ly. On the right-hand side, we need the Laplace transform of e to the negative t. Okay, we look that up in our table, and we see that's going to be 1 over s plus 1. All right, our goal, of course, is to solve for this Ly. So we're going to factor out Ly, and what's left over? We have an s squared, we have a 2s, and we have a 3. This minus 1, let me just move that to the other side. So I have 1 plus 1 over s plus 1. Or if, we want to put this together, I could view this 1 as s plus 1 over s plus 1. And so I could put these together as s plus 2 over s plus 1. We'll see if that makes a difference. All right, again, trying to solve for L of y. So I'm going to divide both sides by this quadratic. So I get Ly equals, and let's see, we have s plus 2 over s plus 1 times s squared plus 2s plus 3. Okay, so if only this right-hand side was in my Laplace table, I could take the inverse Laplace transform and I would have y. But this is a little too complicated to be in my Laplace table, so I'm going to use partial fractions to break it up. So I know this is going to look like something over s plus 1, maybe we'll call it a. And then again, we know this is an irreducible quadratic. We could check the discriminant. Okay, so b squared would be 4 minus 4ac would be 4 minus 12, which is a negative number. So this is really irreducible. So I have s squared plus 2s plus 3, and I have to put a linear term on top. Okay, so we're going to want to actually figure out what a, b, and c are. So let's make a little room over here and do it. So if we cleared the denominator, I would have, so I'm going to do the partial fractions over here. I would have s plus 2 is equal to a times, okay, the s plus 1 cancels, and I get the quadratic. So a times s squared plus 2s plus 3. And then plus, I have bs plus c, the quadratic cancels, and so I multiply by s plus 1. Okay, we notice that if I make s equal to negative 1, the second sum end will go away. So when s is equal to negative 1, what am I going to get? Negative 1 plus 2 on the left, which is 1. And on the right, the second sum end goes away, and so I get negative 1 squared, which is 1, minus 2, so that's negative 1, plus 3 is 2. So 2a is going to equal 1. Dividing by 2, we see that a is equal to 1/2. All right, so we can put that in. So a is 1/2. All right, now we want to get the b and the c. So let's see. We can get the b by looking at the s squared terms. So on the left-hand side, there are no s squareds. On the right-hand side, I have a s squareds, and I have b s squareds. Okay, but a is 1/2, right? In fact, we could just plug that right in. A is 1/2, a is 1/2. So b plus 1/2 has to be 0, and so b has to be negative 1/2. All right, that can go in. Fine, I have negative 1/2. Now I want to get my c. Let's use the constant term. On the left-hand side, we have a 2. On the right-hand side, I have a 1/2 times 3, so that's 3/2, and I have c times 1, so that'll be plus c. So 3/2 plus what is 2? Okay, c has to be 1/2. All right. Well, that's actually pretty nice having this 1/2 everywhere. I could factor that out of everything. So I have 1/2, and then I have 1 over s plus 1, and then negative s plus 1 over s squared plus 2s plus 3. Okay, well, this is getting a little bit better. Let's go down a little bit, give us some room. So let's see. This 1 over s plus 1, we already know that from the table as being the Laplace transform of e to the negative t. In fact, we had converted it to 1 over s plus 1 up above. So I can view this as 1/2 times the Laplace of e to the negative t. Okay, now what about this second bit? Well, this is going to remind us a lot of one of our previous problems. We're going to want to rewrite the denominator by completing the square so that it'll look like something in our table. All right, so let's head over here and say, okay, we have negative s plus 1 over s squared plus 2s plus 3. If we complete the square, we'll have s plus 1 squared. Now let's see, 1 squared is 1, but we really need to have 3, so we need to add 2 more. We see we're getting a shift, right? S turns into s plus 1. So let me turn my s into an s plus 1. Okay, well, this doesn't quite match what I had on the left. This would give me negative s minus 1, right? Distributing the minus. So negative s minus 1, but I'm supposed to have negative s plus 1. So I'm going to have to add 2 more. Okay, so now this negative, I don't worry about that. I can just bring that out front. I'll have negative s plus 1 over s plus 1 plus 2. And then I have a 2 here that just has to stay around. So I'll have 2 over s plus 1 squared plus 2. All right, this first piece is great. Forget the negative for a moment. This looks just like a shift of our Laplace transform of cosine, where the a is the square root of 2. So I can come back here, I can put a minus. I'll have the Laplace transform of the cosine of the square root of 2 times t. Of course, we have a shift, so we have to do e to the negative t. The second one almost looks like the Laplace transform of a sine. Again, of course, you have a shift, but this is a 2 here. This should be the square root of 2. So what could I do? I could multiply by the square root of 2 over 2. Then the 2's would cancel, and I'd be left with a root 2. Well, of course, that's cheating. So I also have to multiply by a 2 over the square root of 2. Okay, so that will give me the root 2 I want on top. All right, so this whole thing is now root 2. By the way, 2 divided by root 2 is also equal to the square root of 2. So what am I left with? I have now a plus. Okay, again, this is equal to the square root of 2. So I have root 2 times the Laplace transform of the sine of root 2t, and again, shifted by 1, so I'll use an e to the negative t. Okay, and so now we've been able to break our L of y up completely. So we take the inverse Laplace transform, and we'll get y equals 1/2. And now each one of these has an e to the negative t. So let's pull that out, and we'll have 1 minus the cosine of root 2t plus root 2 times the sine of root 2t. Okay, and that is our solution to the initial value problem.